Welcome to the Astro Guide by Deep Sky Detail. Can your smartphone really take pictures of the Milky Way? Let me show you what I got with nothing but my phone, a cheap tripod, and some free software. This is the first episode of the Astrophotography Guide where I help you get started in astrophotography. I'm going to show you how you can take your smartphone and get a decent shot of the Milky Way. Now, you may be looking at smart telescopes or tracking mounts. Before you do that, I think you should try simply putting your smartphone on a tripod and seeing what you can do. You can get some surprisingly good shots, even in less than ideal conditions. And I promise the stuff you'll learn in this video will be so useful if you decide to get dedicated astrophotography equipment. I was recently traveling in the Poconos in Pennsylvania, and I didn't have my telescope or any gear, but I did have this tripod with a 3D printed phone holder. I was able to get some decent shots of the Milky Way. Here's one of those shots. I'll show you how I did it. The first thing you'll need besides your phone is some sort of tripod. It doesn't have to be expensive. You also need some way to hold your phone on the tripod. There are a ton of inexpensive options on Amazon. I 3D printed mine. Just set up the tripod, put the phone on it, and point it at your target, which in our case will be the center of the Milky Way. In the fall and winter, when the Milky Way isn't visible at night, Orion is another great option. I'm here, sort of in the middle of Pennsylvania, and I didn't take any astrophotography equipment, but it's a clear night. I've got my smartphone and I've got a tripod, a cheap tripod with some 3D printed parts that can hold my camera on the tripod. And I'm going to try to take a series of images using my smartphone and stack them using software in order to get a nice picture of the Milky Way. It's not anything special, just a flimsy tripod with some 3D printed parts that I can attach the phone into using this mechanism here, and it's just held together with a rubber band. So it's not like this is an expensive setup. If you have just a tripod, 3D printer, or anything that can really hold your phone, you can set it up. Just put the phone in there, then tilt it however you want to, and then just leave it there. I've been trying to figure out, do I want to set the phone up here or kind of near a lake that's in the area where we're staying? And let me show you where that is. Hang on a second. Walking towards the lake now. But again, I've got a nice view on the lake too of the southern sky. I think this would give us sort of a clearer view of the Milky Way itself. So how do I know where the core of the Milky Way is going to be? There's the intuitive way and the let the computer tell me the way. For the intuitive way, there are a couple of easy rules to follow.
Hi, this is Editor Mark. I'm about to give you some quick rules of thumb for finding the Milky Way's core. These are great general guidelines, but they can break down at very high or low latitudes. For example, if you live in Northern Europe, it can be really hard to see the Milky Way core in May or June because there's just too much daylight. And in October, the core may have set for you, but not for people in lower latitudes. So take these rules with a big grain of salt. Also, you might be thinking, why do I even need to find the Milky Way? Can't you just look up? And yeah, if you've got dark enough skies, you probably see it all the time. But a lot of people today have never really seen the Milky Way because of light pollution. So before they travel to a dark site to photograph it, they'll want to plan ahead a little. Don't worry, I'll also give you a more accurate way to locate it.
1. Things in the sky usually rise in the east and set in the west. Pretty crazy, right? There are some exceptions like Polaris and other objects near the poles. This rule mostly holds true for the Milky Way. It rises in the east and sets in the west. The second rule is that throughout the year, most things in the night sky rise earlier and earlier in the year as the year passes. So in May, the galactic center of the Milky Way in the northern hemisphere, we call this the summer Milky Way, might start to rise around 2 or 3 a.m. The sun comes up around 5 or 6 a.m. or earlier, so there might not be much time to image it in May. In June, it will rise around midnight, but by October, it starts to rise around 2 or 3 p.m., And by 8 p.m., when it gets dark, it's fairly high in the sky. And then 3, the core of the Milky Way is in the southern sky if you're in the northern hemisphere. In the southern hemisphere, it might be straight up. That means that the best view of the core is in the southern hemisphere. And armed with this knowledge, you can figure out roughly where to point your camera. Or you can also download a free program called Stellarium. You plug in your location, tell it the time you want to observe, and it will show you where the Milky Way will be. I'm not sure what I want to do. So the Milky Way would probably, by the time the sun sets, be right across here. So that way is south. The Milky Way right now, if it were visible, it would be right here. So in a couple hours, it's going to move here. And we can get kind of a nice picture of the core. The only thing that I am worried about is there might be some local light pollution from the houses over here that could interfere with things. So I've got a couple of nights that I can try this out. I may try this out tonight and tomorrow night. Maybe I can get an hour's worth of imaging in order to really kind of get some good data and process it out. It's a Bortle, again, like I said, it's a Bortle 5 zone, and I just don't know exactly how bad the light pollution is here yet. So you heard me talk about light pollution and a Bortle zone. Well, what does that mean? Well, in astrophotography, Bortle zones are used to classify how much light pollution there is. Bortle 1 is an ideal sky with no light pollution. Bortle 9 is a fully light polluted sky where the sky looks white at night and only a few of the brightest stars are visible. Light pollution, besides maybe weather, is going to be the biggest factor in how good an image can be. Over the whole image, light pollution creates gradients that wash out detail. That's bad, but it's not always a huge deal most of the time. On the smaller scale, in terms of individual pixels, light pollution creates random noise that makes it increasingly harder to image faint detail. In order to overcome light pollution, you need longer and longer exposures, or you need to stack more and more images. We'll talk about stacking in a bit, but stacking lets you combine shorter exposures together to simulate a longer one. Based purely on my intuition doing this hobby, and so take this with a grain of salt, for each Bortle zone higher you go, you may need to increase the total exposure time by 4 times if you don't have any fancy light pollution filters to help block the light pollution. Each Bortle zone, the higher you go, the less faint detail you can capture in practice. For example, in a Bortle 1 zone, you may only need a 10-second exposure to get a nice shot of the Milky Way with your cell phone. In the image, you'll see all sorts of faint detail. In a Bortle 2 zone, you may only need 40 seconds. A bit of the faint detail is hard to see, but it's still there. However, by the time you get to a Bortle 9 zone, you would need like 182 hours of total exposure time in order to get a decent image. And most of the faint detail is unrecoverable. Light pollution sucks. Unfortunately, Bortle 1 zones are disappearing all over the world. But for most places people live, a Bortle 2 or 3 zone is probably about 100 miles or 160 kilometers away if you live in a big city. If you can't travel that far, then a Bortle 5 zone is probably about 30 miles away or less. Lightpollutionmap.info is a great website for helping you plan where to go. So I have a Samsung Galaxy S24, so it's not the latest model, and I'm going to be trying to shoot in RAW format, which, if you're familiar with the S24 and higher, I think the S25 also suffers from this, is that you can't really shoot in RAW natively with the S24. It's really actually like a JPEG format in disguise. The problem with this JPEG format is that you can't stack those images in Serial or Deep Sky Stacker or other stacking software. I've tried it before and it just doesn't work. Luckily for Android devices, there is an app called ProShot, which is, I think when I bought it, it was like $7 or $8, and it's not a bad app, to be honest. There's a free version that doesn't allow you to take pictures, but it allows you to determine what your phone will allow ProShot to access. So there are some features in the ProShot app that are unavailable because Samsung doesn't let that
be available for third parties, which is actually fine for me. I still get access to all of the different lenses. Critically, it allows me to take series of images in true RAW format that can be used in stacking software. So what I'll do is I'll put up on a screen what the ProShot looks like, and I'm going to be trying to shoot all of this in just straight RAW based on only what the camera outputs. It allows me to turn off all of the AI tools that Samsung usually uses when it processes images. One also nice feature about ProShot is there's an intervalometer mode, so you can set the exposure length, the ISO, and then you can set the duration of how long you want the images to be taken. So I could set it for 2 hours and have it take 8-second exposures every 10 seconds. And if you're familiar with astrophotography, you know that stacking is really nice because it lets you stack a whole bunch of shorter exposures, and it gives you the ability to combine them as if it was one longer exposure.
So what exactly is stacking? Let's back up a bit and let me ask you a question. What would happen if you put your phone on a tripod to image the Milky Way and took a 12-hour exposure? Well, lots of bad things would happen for your image. The stars would move across the sky, making things look blurry. You get star trails. After a while, light pollution or the stars themselves would start saturating the image, slowly turning the whole image white. That wouldn't be good. We need a way that we can collect information from the sky that makes sure the stars don't get star trails and the image doesn't get blown out. Stacking is how we do that. Stacking helps us get rid of shot noise or increase the signal depending on how you want to think about it. That helps add detail to the image. By taking several short exposures, we can put those short exposures into software that will line up the stars and average the images. 1 hour of 10-second exposures then becomes roughly equivalent to the single 1 hour exposure, but there are no star trails and the image isn't blown out. It's like magic. Do we have to stack images? Doesn't Samsung have a night mode for this? Yeah, it does. This is what that image looks like using the Expert RAW Night Sky mode. It's about a 10-second exposure. I mean, it's okay, but there's a bigger problem. It's clear to me that the image has gone through some enhancements. There is aggressive noise reduction. There looks like there is a second Milky Way arm here, which may indicate some AI tomfoolery going on. And even though this is supposed to be a raw image, it's really an XL JPEG. It's not a true raw image. I went ahead and took a real raw image using similar settings in ProShot. I'll show you how to do that in a bit. But let's go ahead and show you how I set up the images.
Okay, so I've got ProShot open. I'm going to use the 23mm lens here, but not the 14 or the 66. I actually think the 23mm, it gives me, at least for my phone, the most control, as well as it has the lowest F ratio. You can kind of see some of the stars showing up. ISO at 1600 and then a 15-second exposure with a 3-second timer. Going to do a test shot and see how that goes. This is what that looks like if we zoom in a little bit. You can kind of see the Milky Way. See if we got any star trails. It looks like maybe there are some star trails, so instead of 15 seconds, I might take it down to 8. You can actually see in a single image, it looks like we have some nebulae, maybe the Lagoon Nebula and things like that are visible in the image. As we get closer to the horizon, things get a little bit more hazy. In terms of settings, I've turned, I think, everything off. So lens mode is manual. I'm going to turn all of these corrections off, and then we'll go back just to make sure we have a raw image. And then instead of 15 seconds, maybe bring this down to 10 seconds, and we'll see how that goes. I think we want to turn manual focus all the way up, and we'll try it again. So here we go. Let's check the second test image, see if 10 seconds is better. Zoom in. And yeah, I think we've got better focus. Stars don't seem like they're trailing quite as much. What I'm going to do now is just Go ahead and tilt this up a little bit to make sure we get more of the sky. And then I'm going to click down here, and instead of just a single shot, I'm going to go to time lapse and make sure the mode is on images. We'll do 12-second intervals. Let's go ahead and do this for 30 minutes. Every 12 seconds, it'll take a 10-second exposure. So there's like 2 seconds in between each exposure. And then we'll make sure that we're in RAW. It's on time-lapse, 23mm lens. I'm gonna go ahead and press start. It should start taking pictures. All right, see you in a little bit.
I've got something surprising to show you, but first, let me show you what I was able to do with the first imaging session from Pennsylvania. I ended up with about 25 minutes of total exposure time from that first session. I stacked all those 10-second images and then blended them together with an image I took of myself looking at the stars. I think it turned out really well, to be honest. This type of image is just not really possible in light pollution with just a single expert raw image from Samsung's default camera. Is it perfect? No, but you can see the dust lanes near the core of the Milky Way as well as hints of nebulae. I think it's really cool. I wish I had gotten more imaging time near the lake, but the next day I found some signs that bears were in the area. Because the lake was a couple hundred meters from where I was staying and I had to walk through some woods to get there, I thought I'd image the Milky Way from the backyard of where I was staying. It's a bit of a shame because there were trees blocking the brightest part of the core, but what can I say? I'm a chicken. And because of this, I could do a bit more testing. Remember the expert raw single exposure from Samsung's native app and what it puts out? Well, I was able to compare it with the true raw image from the ProShot app. So let's compare. On the left is the fake Samsung raw image. On the right is the true raw image. Look at how processed, muddy, and just overall gross the Samsung image looks. The Samsung processing just doesn't do well with light pollution, and I think it is mistaking this part here for the Milky Way. The true raw image isn't great either, but the stars look more natural and the galaxy has about as much detail as you would expect from a 10-second exposure in Bortle 5 skies. Plus, you can stack these images to get a better one. Having said that, Samsung has an Astrophoto mode. I think you'll get more natural results stacking the true raw images because Samsung is known for faking their images sometimes. After finishing the first night of imaging, I took 40 minutes of data from the backyard of where I was staying. So let's stack this and process it together, just really quickly. Before we stack any images, we also have to capture calibration frames. The calibration frames help remove imperfections in the lens and the camera. The two most important types are flats and darks. Trust me, you want to put in the effort to calibrate your images. It's worth it. The actual Milky Way images we call light frames, and the stacking software will help use the calibration frames, the flats and the darks, to fix the imperfections in the light frames. A dark frame's job is to help control any hot or cold pixels in the sensor. Sometimes some pixels on the sensor are kind of broken. They're always either too bright, so they're hot pixels, or they're always too dark, cold pixels. What we need to do is just cover the sensor up so no light is getting in the lens and take 10 to 30 at the same exposure length and ISO as the Milky Way images. Ideally, you also want the dark frames to be at the same temperature as the light frames. For my cell phone, I like to cover up my sensor with tinfoil at the same night that I take the light frames outside. Flat frames are also easy. Flat frames help control vignetting in the images, where the corners of the image are darker than the center because that's just how lenses work. When you take flat frames, you want to take a picture of a white diffuse light. It has to be really pretty diffuse or you'll get weird internal reflections with the lens that will mess up the flat frames. I like to turn on a white screen YouTube video, fold paper napkins several times over the lens, and press the lens up to the computer monitor. Then take a few exposures. The most important thing is that the light is very diffuse and that all the sensor has light hitting it and that none of the flat image is blown out to white. I took about 10 flat frames for my image. Now we can stack.
Hi, Editor Mark here again. In the next part, I'm going to stack and process my image of the Milky Way. I moved through this section pretty quickly. If you're already familiar with image processing, you should be able to follow along just fine. but if you've never processed images before, it might be a little hard to catch everything I'm doing. By the time this video comes out, I'll have done a live stream where I go through the same steps much more slowly and explain them in more detail. I'll leave a link to that live stream in the comments. My recommendation is to watch this video first to get a general overview and then check out the live stream if you want a deeper walkthrough. You can always come back to this one later as a quick refresher. And if you are enjoying this video, consider liking and/or subscribing. And if you'd really like to help out the channel, consider becoming a Buy Me a Coffee or channel member. Thanks. I'm going to go over this briefly. Maybe I'll create another video going in more depth. Plus, there are a ton of other great YouTube videos out there that will help, but this one should help get you started. A great program for stacking is Siril. I'll leave a download link in the description. It works on Windows, Mac, and Linux. It's great and can ignore the foreground of the image to make sure stacking goes correctly. This is something that other programs like Deep Sky Stacker have trouble doing, in my opinion. So first, organize all your files into 3 folders in the same directory. We'll call one of the folders flats, one of the folders darks, and one of the folders lights. Set your working directory in Siril by clicking on the home button and choosing the folder with your files in it. Now we need to stack the flats and darks to create a master flat file and a master dark file. Click on the plus button on the conversion tab in Siril to create a dark sequence. Add your darks and the sequence name, type something like darks, then click convert. Go to the sequence tab and make sure that the darks sequence is selected. Then click on the stacking tab. Make sure these parameters are selected. You can pause the video here to copy the parameters that I have. Okay, after you've done that, you can press the stacking button and it'll create a master dark for you in the home directory that you selected earlier. Remove the darks by pressing the minus button. Add your flats by pressing the plus button and then adding them. Now we do the same thing with the flats. So change the sequence name to flats, click convert, make sure the correct sequence is selected, and go to the stacking tab. This time, make sure these are the parameters you choose. Again, you can pause the video here to make sure you've got the correct ones selected. In our working directory folder, the one we choose when we opened up Siril, there should be a lot of new files. Most of the new files you can just ignore or delete. We're looking for the darks_stacked.fit file and the flats_stacked.fit file. Go to the calibration tab in Siril and check use dark and use flat. Then click the folder icons and select the stacked dark and stacked flat files that you just made. Now we need to calibrate our light frames. So remove all the files from the list again and add the light frames. These are the actual Milky Way images that you took. Change the sequence name to something like lights and then click convert. When that's finished, go to the sequence tab and make sure the light sequence is selected. Go to the calibration tab and click start calibration, making sure you have your stacked dark and flat images loaded. Once that is finished, you'll notice another sequence in the sequence tab. Siril has taken all of your images and calibrated them with the dark and flat frames and created a new sequence with a prefix pp_. Make sure that sequence is selected and then click on the open frame list. Here you can look at all your calibrated frames to make sure they look good. Deselect any images that you don't like. Maybe there are clouds in them, for example. Then click on one of the images in the middle of the sequence, and on the image itself, click and drag to make a large selection. It's in this area that Siril will try to find stars. It will ignore the trees, which is good, because the trees mess up the star alignment process in a lot of programs. Then you close the frame list, go to the registration tab, and make sure Match Stars in Selection is checked in order to ignore the trees and only focus on that square. If your image has no foreground, then you don't have to do this. You just click Go Register. It'll take a little bit to register all your images, but once they are registered, you'll have a new sequence that will start with R for registered_pp.
make sure that sequence is selected and go to the Stacking tab. Now use these parameters and take a note of the save in file name. If your sequence is called r_pp_lights.sequence, then the output image will be r_pp_lights_stacked.fit. Go ahead and start by clicking Start Stacking. Serial will stack all the registered images together and then load the stacked image automatically. Now, when Serial opens up the stacked image, the trees will be blurred. That's fine as long as the stars are crisp and unblurred. So as the stars move across the sky, Serial is aligning all the stars, and the result of that is the trees getting blurred. So let's go ahead and rotate it so that the trees are standing up and not on the side. Go to Image Processing, Geometry, and Rotate 90 degrees. Serial will automatically stretch the image with an Auto Stretch Preview. You can change it back to the raw linear image by clicking and choosing Linear. Let's go to Image Processing, Stretches, and Histogram Stretch. Let's click the Auto Stretch button and then click Apply. We could leave it like this and you can have a nice clean image of the Milky Way. You could go to this arrow button here and press it to save. But I actually want to bring out more data in the Milky Way because the data are there. So I'm going to save this image as the foreground and add the processed Milky Way as a layer in GIMP later. So I'll go ahead and save this as a PNG file. Now, let's go ahead and undo the histogram stretch and turn back on the Auto Stretch Preview. I'm going to go to Image Processing, Background Extraction, and make sure RBF is selected and Add Dither is checked. I'll click on a few parts of the night sky, making sure not to click on the stars or the Milky Way itself. Then I'll click Compute Background. What this is going to do, it's going to try and remove all the gradients from the light pollution in the image. It's a really powerful tool. And it will also remove a lot of this blue that is distracting. And once we click Compute Background, you'll see that the core of the Milky Way pops a lot more. You can play with the smoothing slider or two if you'd like. When you're happy, click OK. Now we can go back to linear, so click the button to make it linear and apply the histogram stretch again. Now we'll save this as the background image by clicking this down arrow again. I'll call it Milky Way and save it as a 32-bit TIFF file. I've got GIMP open now, so you can use GIMP or Photoshop or another image processing software. And let's just go ahead and open up the foreground image. Now I'm going to open up the Milky Way image as a new layer. I'll move the foreground image so it's on top. What we want to do is create a layer mask to bring in the green of the trees as the foreground. In GIMP, right-click on the foreground layer and choose Add Layer Mask with white for full opacity. Take the intelligent scissors and start outlining the sky, then take the bucket tool and fill the selection with black. Now, with the mask still selected, go to Filters, Blur, and Gaussian Blur. We can also refine this mask by painting it in with gray around the edges of the trees and blurring the mask again if we need. And this will help the foreground blend in with the sky. What this mask is doing is it's helping erase the sky in the foreground image and bringing out the Milky Way image that we processed earlier. I'm going to go ahead and click on the foreground layer again, not the mask, and go to Colors, Saturation. I'll bring the saturation slider down for the foreground just because I don't want the trees to be distracting from the Milky Way. I think it looks pretty nice. You can keep processing this as much as you'd like, subtly changing the color and blending in the foreground. I'm going to go ahead and call this one finished for now, but I think with stacking you get a really nice, believable image of the Milky Way without AI bringing out fake detail. So to recap, all you need is a good app like ProShot, a dark spot with the Milky Way high in the south, and some patience for stacking. Do that and you'll be amazed at what your phone can do. If you enjoyed this beginner-friendly approach, my next video explains the key astrophotography terms you'll need before jumping into dedicated gear. And if you're ready to sharpen your stacked images, check out AstroSharp, my AI tool trained on real astro data. I think it does a lot better job than Samsung's. Thanks for watching.